Alrighty, welcome to the Algebra 1 unit on exponents and exponential notation. So there's going to be about 10 different sub-videos within this category. Each one should be relatively short and individually posted. So here we go. First video is recursive routines. So this is a list of numbers that follow some kind of pattern. And so the two quantities that you're going to be required to identify for a given pattern is the starting value and the rule. So if you know what number you're starting with and what rule to follow to get from one term to the next, then you should be able to generate the entire sequence. And so the recursive routine is the starting value and the rule, and it generates a recursive sequence. So the rule could be any math operation, could be adding, subtracting, multiplying, dividing, even things like squaring or square rooting, or even more complex things that you haven't even learned about yet. But in particular, our book focuses on the two possibilities. One possibility being adding and subtracting, because subtracting is the same as adding a negative, so those get grouped together as one topic. And the other possibility is multiplying and dividing, dividing being the same as multiplying by a fraction. So for this particular section, since we're looking at exponents, we're only going to be looking at problems where the rule is multiplication. It could be by a number larger than 1 or by a fraction, which is smaller than 1. So dividing by 3 is the same as, say, multiplying by 1/3, something like that. So let me generate some quick example problems to show you what I'm talking about. So suppose you have, I say you start at 3, and your rule is multiply by 2. Then that generates a sequence, start with 3, and then to get the next term in the sequence, you just follow this rule, times 2. So that'll be 6, then 12, then 24, 48, etc. And you can fill in as many terms as you want. The sequence would go on forever. Alternatively, I could give you a sequence, and I could ask you to find the starting value in the rule. So what if I give you the sequence like 8, 4, 2, 1, 1/2, etc. So in this case, your starting value is very obvious. Start at 8, and then look at your rule. So your rule, you might look at it and you might think, okay, my rule is divide by 2, but we want to write the rule as multiplying every time. So dividing by 2 is the same as multiplying by 1/2. So it's much better to write multiply by 1/2 than divide by 2. As you'll see when we get to an equation, we're going to have a place where the rule goes in. So another way of thinking about it is, here I'll just use a little bit of space I have over here. The rule is the ratio between the terms. So how you get from one term to next term is by following the rule. And if you take the ratio of any two terms, then that will give you, so you can define the ratio for any sequence like this as the second term over the first term. Okay, so for example, in this one, the second term is 6, the first term is 3. 6 divided by 3 gives the rule, which was times 2. So the rule is the ratio between the terms. And so a lot of times in these sequences, they'll say what's the starting value and what's the ratio, rather than what's the starting value and the rule. But you should know that those two are the same thing. Okay, so here's some space for some more examples. Let's start with something a little bit more complex. Let's go 15, 10, 6.6 repeating, ... Okay, so the starting value is very easy. Start at 15, and then your rule, which is also called, I'll put here, ratio. This one, you might not be able to look at it and immediately just say, bam, that's my answer, right? So a lot of times you can just do term 2 over term 1, and that way, without even having to think about it, you can just get the answer. So you write down 10 over 15, and then you can reduce this, and you can get 2/3. Okay, so your ratio is 2/3, your starting value is 15. So to get the next term in the sequence, you would take 6.6 repeating and multiply by 2/3, and then take that answer, multiply by 2/3 again, and again, and again, and again, to get all the different terms in the sequence. We'll do one last example. What if I give you start at 2.5, and the rule is going to be multiply by, I don't know, negative 1/5. That could be tricky, right? So start with 2.5, write that down. Multiply by negative 1/5. Well, if you multiply by negative, it's going to become negative, and 1/5 of 2.5 is 0.5. Okay, so to get the next term, multiply negative 0.5 times negative 1/5. Negatives cancel, and you get positive 1/5 of 0.5 is 0.1. And then multiply negative 1/5 times that, and you get negative again. 1/5 of 0.1 is 0.02. And then you could just keep going like this. So you can generate any sequence if you know the starting value in the rule. And likewise, if you know the starting value, if you know the sequence, you can find the starting value in the rule. To get the rule, always you can just divide the second term by the first term and take that ratio, which is why the rule is often called the ratio. Okay, so that's it for this video. That was just an introduction to recursive routines and sequences where the rule is multiplying and dividing. There are also sequences where the rule is adding or subtracting, but we're going to do those in a separate section.